A very interesting word problem for you based on trigonometry, 3D application. I would like you to pause the video, copy the question, answer, and then look into my approach. We are going to visualize the situation, apply the learnings, and provide simple solution. That is what we call critical thinking. In case you want to learn from me, you can join my classes. Send me an email. Gain confidence and get ready for future. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider a challenge question based on real life situation. We are reviewing trigonometry, and here is an example which deals with 3D real life situation. The question is, from a point A, the summit of two mountains B and C are on a bearing of 0.24 degrees and 0.58 degrees, and the angle of elevation are 8.5 degrees and 9.3 degrees respectively. If B is 850 meters above A and C is due east of B, find the horizontal distance from B to A, the height of C above A. I'd like you to pause the video, answer the question, and then look into my suggestions. So first step here you need to do is to sketch the diagram. So I'll wait here for you to sketch the diagram. So step 1, sketch diagram. The idea of this video is to help you solve questions rather than providing you with solutions. From a point A, the summit of two mountains B and C are on a bearing of 0.24 and 0.58. What does that really mean? So if I look into this diagram, from north, it really means that bearing angle is always measured from north, right? So if this is north for you, and that is east, in that case, we are saying that the two mountains are on the bearing of 0.24 and 58. So that could be the position of B from A. And C could be somewhere on this side. So here we are saying it is 24 degrees. Bearing angle, remember this. When we say bearing angle, what does that mean? It is an angle which is measured clockwise from north. You get the idea. Therefore, this is the bearing angle. And it is always written in three places. So therefore, you see 0.24. Do you see that? 0.24. Now this angle is given to us for C as 0.58 bearing. So I can write this as 58 degrees. Now this can help you to find the angle from A between B and C. That's the whole idea. So basically now, from the given dimensions, you can find what this angle is, which is 58 minus 24, and that is 34 degrees. So you get some idea about the placement of all these three things. And now we have an angle of elevations are 8.5 degrees and 9.3 degrees respectively. And B is 850 meters above A and C is due east of B. Find horizontal distance from B to A. Now I'll prefer you to sketch another diagram for the second condition where we are given the angle of elevation. Then it becomes slightly simpler. That's the whole idea, right? So we'll sketch two different diagrams in this particular situation to understand the situation. So I can say that the angle of elevation for B is 8.5 degrees. So angle of elevation, as you know, is from the horizontal, and this angle is 8.5 degrees. The diagram is not to the scale, but it gives you good understanding and gives me space to work with. Now in this particular case, we are given that if B is 850 meters above A, that means this height is 850. So we can look into this piece if B is 850 meters above A separately, rather than combining these diagrams together. Because if you combine them together, it becomes too complicated. Now, we know that the point A is from where we are looking at, and what do we need to figure out is the horizontal distance from B to A. Now that part should be simple. Now horizontal distance is projection of B on the ground. Let's call this as B dash. Now that becomes a right angle triangle, correct? And in this right angle triangle, we can find A, B dash, and that is what we need to find, right? So this is equal to A, B dash. You get the idea. Well, you can now pause the video and find what distance A to B dash is. That is the horizontal distance from B to A. Well, the triangle gives us the opposite side, and we are interested in finding what? We are interested in finding the adjacent side. So therefore, we know SOHCAHTOA, right? Sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. So it is the tan ratio which we can now use, correct? So we're going to use the tan ratio to find A to B. So we can say that tan of 8.5 degrees is equal to what? Well, tan of 8.5 is 850 divided by AB dash. And that gives you what AB dash is, right? So AB dash is 850 divided by tan of 8.5. Now you can use the calculator and write down the approximate answer. Is this part clear to you? Correct? So you can now divide 850 by tan 8.5. What do you get? Let's do it. So I'm just calculating the value and it gives me 5687.48. So I'm going to approximate it to 5687.48. I'm approximating this to 5687.5 meters. So that becomes my answer for the horizontal distance as 5687.5 meters. Does it make sense? So see, this is how you could actually approach this 3D equation and then solve. Perfect. Now let's move forward and find the height of C above A. At this stage, you can actually pause the video and answer the question further. Perfect. Okay. So once again, we'll need to sketch the diagram. So let us sketch the diagram and then find the solution. We already found that this distance was 5687.48, which I rounded to 5687.5 meters. Now let us see, how do we find height of C? So to find height of C, we can use the angle of elevation in formation. That is, of course, one thing. And the other thing is that we have to first find the distance from A to C. How are we going to do that? So let's look into the diagram once again. Right. So what we had was this 3D position. And in this position, we had drawn B and C. Now C is on the east of B, right? So as you can see here, C is on the east of B. So that gives you an idea. And we just calculated that this angle in between A, B, and C is what? The angle in between A, B, and C was 58 minus 24, which was 34 degrees, correct? Now to solve this question, we could again look into their projections on the ground. So when I say projections on the ground, in that case, what I could do here is draw a kind of 2D diagram. Now, so we'll look into, instead of B and C, we'll look into the points B dash and C dash. You get the idea. So what I'm saying here is we can say that in 2D, I could sketch like this as my north, and here is east. So on the plane, when you do the projections, in that case, you can think about point B. Let us say that's the ground which we are talking about. So in that case, from B, we'll get the A is already on the ground, right? So we are looking at A level, which is at the ground. So from A, we are looking at a point which is B dash, that is the projection, and then C dash. You get the idea. And we will find now the distance from A to C. This is what we are going to find. We already know that A to B dash is 5687.5. Right? Now, what is this angle at B? We know this angle here, that is 34 degrees. This angle should be how much? Clearly, this angle is 90 plus 24. Look at here. Since this is 24, right? So, we have 90 degrees here and 24 as the alternate angle. This angle is also 24 degrees since it is an alternate angle. And therefore, the angle here is actually equal to 90 plus 24 degrees. You get the idea. Which is 114 degrees. Once you know that angle, you can calculate the third angle. Once you know that angle, you can calculate the angle at C. So angle at C will be 180 minus 114 minus 34, correct? So you know all the three angles. Minus 114 minus 34 gives me an angle of 32 degrees. Now you can apply the sine law. We have one combination in which we have the angle and the opposite side. So when angle and opposite side are known to you, you can apply the sine law. So I hope it is absolutely clear how we can solve for AC dash now. Since in this triangle we can apply the sine law, let us find what AC dash is. So AC dash divided by sine of angle opposite to that, which is 114, should be equal to 5687.5 divided by the angle opposite to that at C dash, which is 32. So that gives us AC dash as equal to sine of 114 degrees times 5687.5 divided by sine of 32 degrees. You can now use the calculator to find this length AC dash. So AC dash works out to, let's calculate, sine of 114 times 5687.5 divided by sine of 32. 9804.87. I'm rounding it to one decimal place, 0.9 meters. So what we get here is the distance on the ground between A to C. You get the idea. But what do we need to find? We need to find the height of C above A, correct? So we have 9804.9 as the distance on the ground from A to C dash. Now let us find the height of C. So for that, we are going to use the information of angle of elevation. So the angle of elevation for C is given to us as 9.3, correct? So now we'll draw our triangle. We know that A, C, and C dash, the projection A to C dash was calculated as 9804.9 meters, right? So let me write down this under this 9804.9 meters, and this angle of elevation is given to us as 9.3. We need to find C dash. We can use the tangent ratio, right? So we know that tan of 9.3 degrees is equal to C dash, the opposite side, over AC dash, and therefore CC dash is equals to AC dash times tan of 9.3 degrees, and we can write this as 9804.9 times tan of 9.3 degrees. So you can use the calculator to figure this out. So I'm going to multiply this answer for tan 9.3, and that gives me 1605. So 0.609. So I'll write 0.6 meters. You get the idea. So for this, we get the answer 1605.6 meters. So we have both the answers 5687.5 meters, the distance of B from A at the ground level, or the horizontal distance I should say, and the height of C above A, which is 1605.6 meters. Is that clear to you? So basically, sketching diagrams really help, and that too in stages as we proceed forward. If you try to sketch all the things in one diagram, it becomes extremely complicated and becomes very difficult to move forward. And that is why I wanted to share with you this particular approach in solving such questions. I hope it makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that will be great. Thanks for your time and all the best.